Hey guys, in the getting up to speed intro, I described what your home lab could look like so you could start getting an idea of where we're going with this. In this presentation, I wanted to start describing the skill set that you'll want to build up to get to that point so that you can deploy that into your home lab. And this is how we're going to do it. Pretty traditional path that I think just about everybody does. You start out with kubectl, you progress on to using a Helm chart, and then you move on to GitOps using Argo CD. So kubectl allows you to just deploy things out manually. Helm chart lets things be templated by another team, and then you can customize the template. And Argo CD, it's just using the Helm chart, but it has some extra benefits that make it absolutely worth the effort. So let's get started with kubectl. Okay, so first let's figure out what image we want to use. And I was thinking to use Pi-hole, but it looks like that's requires a more sophisticated setup than we want to do initially. We just want to set something up with a single container that's going to be verifiable in the simplest way. And I'm thinking just setting up like Nginx is probably the way to go. So you search for Docker and the image that you want to run. Maybe we'll add in like a Docker IO, because really we're looking for the image at Docker Hub. And there we go. And it's saying all we have to do is a Docker pull Nginx, so it's going to be similar for Kubernetes. And what I'm hoping to see here is what port that it uses internally. So it's probably going to be like 8080 or 80. Okay. So this is showing us using a Docker command that the container uses port 80. So we're going to do a similar test, but we're going to use Kubernetes. So let's go ahead and switch over. All right, so here we are running on our demo cluster that we created earlier. There's really not much here. It's pretty much a cleanly built cluster. And there's nothing running here in the default namespace, but let's go ahead and create a namespace and put Nginx in there, because generally that's the way it works. One namespace per application with all the microservices involved running in one namespace. So I do have an alias for kubectl as just K. And I can also switch namespaces with K and S. So now we're in the ASDF namespace. There actually isn't a namespace called that, but you can still send the command to change into the namespace, because really we're just, it's client side. This is what we're trying to work within. So we can say we're trying to work within this namespace when we send a command, and then we'll get the result, right? If you're trying to run something and you're not in the right namespace, you'll get that result. But since this is more of an intro video, I'm going to use the full command. So first, let's create the namespace. We'll just say Nginx. Then we'll change into that namespace. So this is what the alias KNS is actually doing. But there we go. We've created the Nginx namespace. We've changed into that. So let's go ahead and create a deployment to deploy out Nginx. So we'll do kubectl deployment or create deployment. We'll name it Nginx, and then we're going to use that same image. In this case, it just said pull Nginx. Sometimes you have to pull library / and then the name of the container. That's why we checked Docker first, because that's where we're getting the image from. Watch this be created, and it's super fast. So there we go. The deployment created a replica set. The replica set created a single pod, and that's what we were running there. So in the way that Kubernetes does, if I do a wide listing here, we can see the IP that it's actually using. So that's a cluster IP. So if you have, say, 3 worker nodes, they all have this cluster IP in between them. That's what Kubernetes offers. So if you run a couple things on 2 different worker nodes, they can communicate as if they're on the same subnet. But that's hidden from the world, right? That's essentially what a cluster is. It's this networking that's hidden and then you have Kubernetes that does the load balancing. So how can we test that this is running? So we can run Google or Google Chrome. There we go. Throw that in the background. And then we can run a command to port forward from that pod using 8080 localhost on my machine to 80 inside the container, similar to what Docker let us do. And then I'm going to switch over to that Chrome instance. Oh, that was me testing earlier with Pi-hole. Let's just go ahead and test this with Nginx. And there we go. So localhost 8080 is redirecting into that container running at port 80. We are good to go. But what if you actually want to use the website without doing the port forward? Well, you turn this off, head back in. You have to expose that deployment. So we're going to expose the deployment named Nginx using listening to port 8080 coming in. That's our ingress port. And the target port in this case is 80 because inside that container, Nginx is set up to use port 80. All right, so now we have our deployment, which creates the replica set, which creates the pod. And now we also have a service. So you use expose to create it, but then they call it a service. And you can see what it's listening to port 8080. Now that's also set up with a cluster IP. Let's make a change real quick. So I'm going to edit that service. And instead of, let's see where the type is, cluster IP, we're going to change this to load balancer. Is it load balancer IP or just load balancer? Let's see what happens. I think we got it. All right. Because the infrastructure has been set up with a load balancer IP range, if you ask for one, you get one. And there it is. So within my lab environment, this is an IP that any machine with that environment can access this website on. So let's go ahead and try that again from our Chrome browser. In this case, it doesn't have to be the local host Chrome browser, right? It can just be any web browser. Let's see what happens. So it's still using 8080. And there we go. So I'm not using HTTPS in this situation, but we are now able to access in the container running an Nginx website from the outside world in through that service into the container. And there we go. If we just add certificates, we can set it up for TLS and start to improve things. But this is good enough for a demo for kubectl. Let's go ahead and move on to a Helm chart deploying Nginx as well. All right, guys, so let's go looking for a Helm chart for Nginx. So typically what you end up doing is you just do GitHub, Helm chart, Nginx, or whatever application is that you want to deploy out there. And just to give you another example, like here's a GitHub, Helm chart, oh, I don't know, WordPress. All right, immediately you get something. So here's like a Helm chart related to stable WordPress. And we could use this to deploy out WordPress. So you can see a pattern here where they have, here's where you add the repo to Helm, and then you do a Helm install, give it a name, whatever you want to name your release, and then you specify the chart. So the reason I jumped over to a different chart like WordPress is if you, in this example, we're using Nginx, but there's this other product called an ingress, which is associated with Nginx. And Google thinks that's probably what we're actually looking for. So it's not immediately popping up. And that's what I wanted to show you, that you usually can just put a GitHub Helm chart and then what it is you're looking for. So in this case, though, because I've done a little bit of research, I'm going to do GitHub Helm chart, Nginx. But then I'm also going to just throw in Bitnami, which is a company associated with VMware. Scroll down here a little bit. So we got GitHub Bitnami charts, and they have lots of Helm charts. So just for the purpose of this demo, we're going to use one of theirs. And I from prior experience, you can browse into their chart directory and you see there's quite a few here. And you're going to find that, right? As you search for Helm charts, as you enter in this phase after you've used kubectl to do everything manual and you've started discovering, oh, Helm charts already exist, you'll find there's several companies out there and they all seem to start building up their own library of Helm charts, and which they use or maintain, whatnot. So let's just scroll on down to Nginx. So just Nginx, the web browser, or the web server. All right, we're starting to see the same kind of common things. So we can do a Helm repo add, name the repo. So I'm going to switch over to my other. Copy this. So I may already have this one added. Let's give it a shot. Bitnami. I'm going to give it an alias of Bitnami. Yeah, already exists. You usually want to do a Helm repo update. Let me just hide that from the screen. I've got quite a few repos that I'm using. I don't want to bother you with all that distracting information, but we can switch back over and it's like, okay, well, after you've created or added the repo, you've updated things, let's go ahead and try installing Nginx. Let's switch back over. So I'm going to call this deployment Nginx. And because we're doing it all with Helm at this point, I'm going to say create namespace if it doesn't exist and use the namespace Nginx. Oh, yeah, let me correct that. The alias we gave for the repo is Bitnami. And there we go. It says it's deployed out Nginx. So if we look at our namespaces, now we have an Nginx namespace. We can change into there. I'll just go ahead and use my aliases here since this isn't really about kubectl at this point. What's deployed out? And it's pretty much the same basic stuff. So if we had a much more advanced, much more complex application, you would get more here, right? So if you deployed out WordPress, you'd get WordPress and a database and the services associated with it. In fact, why not? Let's go ahead and do something a little more complex than just this basic one. Although, maybe real quick before we do another, we can just test it. It went ahead and set up this external IP as well. So we should be able to access this Nginx instance on my machine. And there we go. So remember how last time we had to say 8080? So this is definitely a different instance. This is the instance that was set up by Helm. Let's try one out that's a little more complex though. Actually, let's go back. Let's find another. I like Pi-hole. I think that's a pretty fun one. This is network-wide protection for your. It's a DNS server essentially, and if it tries to resolve a URL that points to an ad company, it just doesn't work. So in your home environment, if you use this DNS, all your machines will have less ads. And in my case, I have a VPN that connects to my home environment, and then I use this DNS, and my mobile gets less ads, which is great. So I recommend that for sure. So let's try to deploy that out using a Helm chart. So if we do GitHub, Helm chart, Pi-hole, Let's just go for this first one. So there we go. This is our, we're going to add this repo. Switch over real quick. We're going to add the Mojo repo. Repo update. We'll hide all that from you. Switch back over. And then here's our install. And we're going to change the release name. Switch it back over. So we're just going to call it Pi-hole. And let's create the namespace if it doesn't exist. And we'll use the namespace Pi-hole. All right. Let's look at what's going on. Oh. All right. So you can see here, we got more, right? So instead of just the deployment and the release, or the replica set and the pod that you're familiar with and the service, we ended up with 4 services, right? So this is Pi-hole, which does a DNS service, and it does both the UDP, which is, old style DNS, and TCP, which is something new people are doing. And this one, the server could also act as a DHCP server, so that's there. Maybe you want to just turn that off. And then we've got a website that we can access. So by default, this is just a default Helm deployment. We're getting the default values. So with Helm, you specify a values file to customize the installation. So if we used WordPress, for example, okay, we get WordPress, but we still need to specify the website URL, right? Because it's your website. But everything else can be templated. Somebody else can configure setting up WordPress and configure a database and get those two talking to each. So you don't have to worry about that. You just have to give it the name of the website. So let's just head back over for a second. So what you can do, and you'll learn all this as you go, experiment with Helm charts. This is what you're going to do. You're going to end up on their GitHub site, and you're going to go into the chart site. And templates is where all those objects are, right? Like here's the services, right? DHCP, TCP, UDP, that was just set up, right? It's all here. But then how do you customize it? So you just come back up one, and then here's the values file. So these are the default values that you just set up with your Helm chart because you didn't specify anything. So if you specify any of these values, what you specify overwrites the default value. So let's see. Let's see if there's one we could do for like to disable DHCP. Okay, so here's service DHCP. Is it enabled? By default, it's enabled true. All right, so let's try to experiment with this. Let's try to set that service DHCP enabled true. Let's change that to false. So just to show you how it's done, we're going to Helm uninstall, or is it remove? Helm uninstall Pi-hole. Then we want to set that value. So here's our values we can specify. Values in a YAML file or in a URL. We actually just want to do it. It's been a while, so let's look it up real quick. How to specify a value for a Helm chart installation. Helm installation example. So here they are giving an example with WordPress. Now they're starting to talk about the values. We want to use the set command. See some examples. All right, so set, and then an example like that. So switching back over to what we want to set. We want to set the service DHCP. So we've got set DHCP.enabled equals false. Let's see how we did. You see, DHCP is gone. So that's how you customize it. Whether you either do it on the same line like that, let's just uninstall Pi-hole. We can do so temp values.yaml. We'll say service DHCP enabled false. So just to show you the difference between using a values file, if I deploy it again, we'll do okay get all. There's our DHCP. So we'll uninstall that. Then we'll deploy it here, but we'll say values file. And then we'll specify that temp file that we just created, values. And if all goes according to plan, there we go, no DHCP. So see, you can either specify it on the command line or you can specify it in a values file. And the values files can get more complex. So moving on to Argo CD, what we're going to do is we're going to put that values file into Git. We're going to tell Argo CD to look into Git on what it should deploy out into the environment. All right, we're going to give this a shot and see if we can get everything first try. So I'm going to just temporarily switch it over to a cluster where I have Argo CD running. Let's not get distracted by Kibana and something else I'm working on. And I'm going to copy a login to Argo CD. I'm going to use the Argo CD URL. Let's log in. We're going to add this cluster, the demo cluster. Give it a name. We're going to specify our kube config. Yes, we're going to add a service account, which allows Argo CD to manage that demo cluster. All right, and then right now we are in our Git repo. So in our Git repo, we've got this basic format, right? So at the root, we have an application set. That's a concept, a kind of Kubernetes object that Argo CD works with. And that defines the application that we're deploying out. And then here under base, we have a Helm chart. And this is a Helm chart that we've created. So at the root, if we go into base, we have a couple files when it's a Helm chart. We got the values that we just talked about in the last video. And just to show you, there's a lot more in there for this demo. I've gone in and customized these values for something relevant to our situation. And I've added a password in. It's a demo password, not a real one, but just for this setup. We're saying to set up persistent volumes, right? That's something else you're going to have to learn down the while. We're turning off DHCP, that we talked about, and a few others, right? We don't need to go into those details because they don't really matter. I am saving this Git repo out there so anybody can look at it and you guys can try to deploy it into your environment. However you want to do that. You're going to want to change the password if you do. Or in my case, I don't put passwords into Git repos anymore. I think that's something that people typically do in the beginning. It's somewhat of a bad practice, although I would argue that using GitOps is the way to go, and that might just be the first way you do it when you're learning GitOps in like a demo environment, and that's just fine. But later on, you're probably going to use something like external secrets. That's what I do. External secrets hooked up to a vault somewhere, either HashiCorp Vault or like Azure Vault. Everybody seems to have a vault these days. And from the vault, you can register the cluster and it will update secrets from the vault, right? So you can put everything you need to access the vault in your cluster. That's a whole nother topic. But essentially, I could set that up and allow you to look at the Git repo and you wouldn't see my passwords, but I could literally deploy it into my environment and it would work just fine. And that's the way to do it, right? No passwords in Git, but it's in there now because we're just right at the beginning of demos. I'll just give you a glance at this application set. So here we are. We're just to give a quick overview, we're calling it Pi-hole, and it's deploying to the Argo CD instance that we're talking about. Argo CD, in my case, is deployed into the namespace of Argo CD. So when I add this application set, I'm adding it to a cluster where Argo CD is running, even though the demo cluster is a completely separate cluster. Argo CD can manage multiple clusters. And we're using this generator here to target the cluster we want to use. In our case, we're using the demo cluster, the one we just added, right? So it should work. And some of this has some dynamic variables, right? So this is pulling this kdemo name to give us a name within Argo CD. It'll be k-demo Pi-hole. I don't want to give too much information here. I'm just trying to give a light level overview. Here's the values, another opportunity to set values within Helm. And I use this so that I can use those aliases, right? So we end up with like the URL that we're trying to access the website with. I form that dynamically using Pi-hole and then the name of the cluster. And then I tack on k.home.net. That's all for stuff we can go into down the line. Let's just see if it even works, because there might be some details here I haven't worked out yet. After all, this is the first time I'm deploying something from Argo CD into a demo cluster. Let's just give it a shot. So we're going to deploy an application set. An application set generates an application. Okay, so here we are over in Argo CD. And I've selected the cluster here. It's down on the left. It's a little off the screen, but let's click on what's going on. See if I can shrink this down. A little too small to see, but I'll remove myself from the equation. So essentially you have all those different pieces here, and Argo CD's bringing all that to life, right? And our demo cluster doesn't have a PVC. So this part's going to fail. So this may not actually come up unless we turn off the PVC. So let's do that. Let's make that change. So I'm going to switch back over. Come back in here, and let's make that change. So in our demo app, we're going to base values, the persistent volume. We'll say no. So whatever settings we set up in the config file after the fact, those will be lost if you restart the container. But since we're adding in our password here, and since we're setting our DNS here, those will persist. And do you really need much else to be configured? In any case, let's give this a shot. So I'm going to update my values file, remove PVC. All right, we'll switch back over. We'll hop up to the top. Let's refresh. All right, so it pulled out the PVC. We're no longer adding that into our deployment. Everything else is looking pretty good. We can click here to look at what's happening. We got the events, so it's pulled the image, right, starting the container. Let's look at the log file. It's got stuff in there, right? You can see the time zone that we were passing in. It's doing all its configurations. So this is just standard log within the container. We can look at that through this Argo CD GUI. It's pretty much there. I wonder what it's waiting on. So we can follow it as it's displaying more. See if I can resize this screen a little bit. So we can scroll down. Oh, app is healthy. So there we go. it believes everything's good to go. And we can switch over back to our cluster. And we're in Pi-hole, so we can see the pieces. So what's especially interesting is I can do destructive things, like delete all the services, and then we'll quickly try to bounce back over here. And it can see the yellow there? Not quite fast enough. But you saw what happened, right? It restored them, right? So it's watching get, and it said, wait a minute, the state's changed. It's supposed to be one thing according to get, but what actually exists is different. So let me fix that and make it match with get again. So it's got these self-healing properties. And essentially what you end up doing is you only work out of get. You don't really have a reason to use kubectl anymore directly. Other than some random some situations for troubleshooting it can be useful, but I mean the end goal should be, I would think, pretty much only interaction with your clusters should be done through Git, which is what you get through using GitOps and Argo CD. Love this product. Okay, you've got a lot on your plate if you're watching this video and you're just starting out, right? So if you're putting your home lab, your lab environment, wherever your lab environment is together, and you've checked out the intro video and you can see like, here's some things you might want to start deploying out into your clusters, things that you can do in your voyage, right? Getting started. And now this video, which is talking about using kubectl and then on to using Helm charts and then on to using Argo CD and GitOps, just take your time. Don't, there's no rush. I'd say it probably took me like a solid year to start feeling like I had this Kubernetes is more of a tool in my tool belt, right? Rather than something new that I was learning. I wanted to just throw out an idea though, something that's helped me all along the ways. Once I discovered Argo CD and GitOps, there's this idea that you could just delete everything and it just comes right back up. You saw how we deleted some services and they came back up. You can use a concept within Argo CD called app of apps, which will allow you to deploy one app, and the result is it deploys all your apps, right? So there's this idea of kind of a Phoenix setup, right? Where maybe you have, I don't know, some arbitrary number of clusters, a couple more management clusters at the base, and like several other clusters, like a production cluster, a non-production cluster, an exposed cluster where you have things like a DMZ kind of thing. And if you just delete all of them, is that a tragedy? Well, if you're using something like Cluster API, which uses YAML files in combination with Argo CD, you have to set up Argo CD initially, right? But then you can use those YAML files in Git to redeploy all your clusters out automatically. Then you can like run another command with an app of apps, which starts deploying all your apps back out to those clusters. Of course, if you have data that needs to be stored somewhere, if it's not backed up somehow, it would need to be in an external database in order to recover that. So I'm not saying this is necessarily possible, but just as something to motivate you. If you could use a motivator, this one has worked well for me, but maybe not just yet. Just get some things. You're probably still learning just, kubectl to begin with. So just give it a go. Just hang in there. I'm trying to motivate you with these videos, not overwhelm you. And it's been super fun for me. And I suspect if you've made it this far, you're probably the kind of person who would absolutely enjoy this technology. And it's definitely future, no question in my mind. I hope this video has been useful. Have a good day. Thank you.